Well, good afternoon, everyone, and welcome to the 2020 Construction Engineering Technology Capstone presentation. I appreciate you joining us through the Zoom meeting today. It's a little bit different this year. It's different because we have teams that are presenting in two rooms. We could allow students more time to make their presentation by doing it in two rooms. And the other reason we're doing it through Zoom instead of doing it in person. So I must give a big hand to the students that they have not seen me since back in March in person. Everything that we've done, all the preparation, all the studies have been done through Zoom meetings. And I must say they have done a fantastic job. This year's project, in this particular room, 4 teams will be presenting their projects about the rehabilitation of the Chalmette Slip, Wharf A in Araby, Louisiana. This is a tough project, but I have to hand it to my Louisiana Tech students. They did a fantastic job in studying, researching, figuring out how to build it, and coming up with a game plan. So if everyone is ready, I will unmute the Nailed It construction team and they'll get started in just a moment. The way we're going to handle questions to keep the back noise down is keep everybody muted except the ones that are presenting, and do your questions through chat. The students that are presenting will be able to see your questions. They will read the questions and then respond verbally to them. They'll not respond through chat, but they will respond verbally to you. So if the Nailed It construction team will hang on for just a moment, I will get you ready to go. Okay, guys, it's yours.
Hey, Mr. Jeter, will you please allow me to share my screen, please?
You should be able to share it. Alex?
Yes, sir.
All right, hold on just a second.
For some reason, it's that the host disabled participant screen sharing.
Okay, Alex, will you try it now, please?
Okay, first and foremost, thank you guys so much for being here. We are Nailed It Construction. My name is Alex Villarreal.
I'm Colby Holmes.
Grant Pryor.
I'm Ty Mullins.
Nailed It Construction, and we're excited to present to you our senior capstone project, which is the Chalmette Slip Wharf A reconstruction.
Okay, so as Mr. Jeter said, we were assigned with the rehabilitation of the Chalmette Slip located in Araby, Louisiana. The slip is used to unload and load barges coming down the Mississippi River. We're acting as an independent cost estimators, providing a schedule and an accurate construction cost for the task at hand.
So the project's located at the Chalmette Slip, right off the Mississippi River in Araby, Louisiana. It's located about 7 miles away from New Orleans, and the location was very important to consider when estimating and scheduling for this project. And the Chalmette Slip is a potential home to many job opportunities and unlimited resources via the Mississippi River.
We were responsible for estimating and scheduling Wharf A. Our scope of work includes the driving of sheet piles, timber piles, and steel pipe piles, placing U-beams, box beams, and girders, pouring a load transfer platform, an overall slab, and finally pouring a retaining wall. We will be going into more detail on all of these activities throughout the presentation.
I'm completely frozen. Okay. So as we talked about in the last slide, we'll bring in our 48-foot pipe piles on a hopper barge. And then we'll have 2 deck barges to set cranes for the pile driving. The cranes we'll be using are 4 Maniwak 4100 cranes, 2 on land, as I said, and then 2 on water. Whenever we came across using 4 cranes, we thought to ourselves, it may be a little much because we're limited to space, but we saved a lot of time and money after putting them into heavy bid. And as soon as we get done pile driving those, we get 3 out of the way immediately. So it'll save us time, money, and efficiency. And the boats we're using to tug the barges are 2 tugboats at 1,800 horsepower.
All right, so our first activity was to drive our sheet piles. We're going to do this with a vibratory hammer with 1 crane on the outskirts of the load transfer platform on land, and then another crane in the water on a barge, as Alex was just talking about. And then the sheet piles will be shipped to us via truck to the land site. We're going to make sure that these sheet piles don't come in at a rate where it clutters the job site. We're going to drive them as they come in. And then we're going to move on to our timber piles. The timber piles will be driven in the same area around or inside the area that the sheet piles create for our load transfer platform. They will be using the same 2 cranes, 1 on the barge and 1 on land. Each of these will be using a diesel hammer instead of a vibratory hammer. These are a lot bigger piles. We'll have these timber piles shipped in by truck as well, and they'll be shipped in while pile driving is happening. There's 1,532 of these piles. That's a lot of room to take up on land. We're trying to make sure we keep the job site as clean as possible because we don't have a whole lot of area to work with. And then while both of these are going on, while the timber piles and sheet piles being driven, we'll have our pipe piles being driven further out towards the Mississippi. These are the 48-inch pipe piles, and they will be driven by 1 barge crane and 1 land crane as well. All of these cranes are Maniwak 4100 cranes, and these cranes will be equipped with diesel hammers as well. The way we're going to get these 48-inch piles in is we have a barge coming in with half of the piles to get us started. And whenever we start getting close, we're going to get the other barge to come in, bring those piles in. We can get 1 barge out of there. The 2 crane barges will be set up on either side of this pipe barge, and so they'll be able to work from there.
So after the piles are driven, we're ready to move on to setting the U-beams. The U-beams are going to be set perpendicular with the slip using the crane to set them in place. And on top of the U-beams, our girders are going to be set, and those are going to be running parallel to the slip. The box beams are going to be set on the outer edge of the U-beams, and they're going to be at the furthest point of the wharf.
All right. Mr. Jeter, could you allow me to share my screen? Because I believe Alex got kicked out or something. Just for this next slide, I have a list of all these structures that I wanted to talk about on our PowerPoint.
You should be able to share it. You're a co-host.
Okay.
You- Click share screen, Colby. I'm not sure what's going on with the internet, guys.
Can y'all see it now?
Yes.
All right, so here's a list of our concrete structures for this project. For these items, we'll be using Class A1 concrete and nearly 1 million pounds of rebar. We'll be using an allowance for wood formwork for most of these items, but our deck slab and our load transfer platform will have steel deck forms underneath them that will be set by cranes.
During the course of this project, we have a lot of concerns that we want to make sure that we take care of to make sure that the construction process goes smoothly. One concern that we have is making sure that we have our activities lined in a way that we can be the most efficient possible. As I was mentioning earlier, be driving the steel piles at the same time we're driving the timber piles. We want to make sure we can do this and make things efficient because we're paying for the equipment rental and we're paying for this labor no matter what. So we want to make sure they get as much done as possible and there's no downtime. Another major concern we had when scheduling our project, as you can see, that little purple pin on the picture on the left, that's our work area. And right behind that would be our laydown area. There's just not a whole lot of space there. And so that's why it's so important that we get those timber piles in as we drive them and we keep our pipe piles on the barge to save as much on land space as possible. And then another concern is just weather days in general. We're only working 5 days a week, 10 hours a day. So a lot of the weather days can really put a damper on our project and really kind of push back our due date. Well, another problem considering weather is another huge portion is the fact that this is right next to the Mississippi River, right off of it. And so what we did was we estimated a project shutdown from March 15th to May 15th. Due to the flood stage in Mississippi River. This is usually the time of that high water hazard, and we don't want to endanger any of our workers in something that's going on that we can't control and it's so rapid like the river rising. If this doesn't happen, it'll just it will actually just positively affect our schedule and our costs. We'll be able to work through it, but we decided to include it in our schedule and our costs just in case it were to happen. We did that after consulting with Mr. Jeff Poche and told us the dates that would be a good start to account for this problem. Another thing that we did that's not usually included in a lot of construction projects is we did a 5% marine upshift in our workers' comp because it's so much more dangerous working over water than what it would be working over land.
So we used a 1% bond and 15% markup on the project, including all construction costs, equipment, labor, and markup. Our final cost will be around $21.9 million. The project is set to begin on June 1st, 2020 and finish October 22nd, 2021. This includes holidays, rainouts, weekends, the project shutdown that we talked about, coming out to a little under 17 months.
To help verify that rather large number that I was just mentioning, we attached a couple of our quotes into our PowerPoint. Almost all of our quotes provided by Mr. Jeter, except early on, before we got any quotes, we immediately started working on this estimate. And we thought the first thing to look for would be the concrete, because it's pretty easy to call a concrete plant and ask how much it is per yard for what the plan specify for the concrete to be. So we started off reaching out for any company that's within 30 miles of the location of the job site. And we actually, Mr. Larry with Dylan Rose Concrete was the cheapest and also the most helpful. He told us a good bit of information. So that's one of the quotes on it. It was pretty close to real life.
So here's a screenshot of our heavy bid file for our estimate. I have open for you our activity crew for driving our timber piles with our material, our labor, and our equipment quantities and prices. Heavy bid was really useful for this project because it allows us to enter our crew with our equipment and our labor for our equipment and labor information for a particular item, and then we can just enter our production rate after that, and it will provide us with our total cost and our unit cost for that bid item.
All right, this is our Primavera P6 schedule. Primavera P6 is the software we use to schedule this entire project. So I'm just going to kind of walk you through what you're seeing here. On the left side of your screen, these are all our activities that we put in. These are activities that are big enough to take up a good amount of time and to schedule for. And we've organized these under their appropriate subcategories. What we would do is we would put in our activity into our heavy bid, and like Grant was saying, we would put our production rates and our crew costs and our materials costs in there, and that would give us a duration for whatever activity we were calculating for. So we'd take that duration and we put that in this P6 schedule, and it would auto calculate as we go, and that's what gave us our finish date at October 22nd, 2021. On the left side of your screen, you see these red bars. Those red bars are the critical activities. Those are things that cannot really be pushed back, hardly any, if you want to finish by the date that we gave you. And those green bars are things that are not so critical activities. So say you have something coming up that you need to get done before a day that you know you've looked at Weather Channel and you know it's going to rain. Those are the things you can push back, and you'd rather push back those green things a couple of days maybe than the red activities. The lines in between these activities are their relationships. That tells you what can have a start-to-start relationship, what can have a finish-to-start. So like, for instance, going back to those timber piles, we want to start driving as soon as we start getting the trucks in. So that's a start-to-start relationship. But for the coping, you can't pour a coping on the sheet piles until the sheet piles are done being driven. So that'll be a finish-to-start relationship. Also, we put in our weather days into this software, and that auto calculates, how many days we're going to have off for the weather in each month. And we put in our holidays to make sure that we're not working these guys on Christmas morning. And we also, if you see that little gray area on the right side of your screen in the month of April of 2021, that's actually running from March 15th to May 15th. And that's our project shutdown that I mentioned earlier due to the high water stage.
Throughout the process of putting this estimate together, we have a few different references. There's no way we could have done this without these means of resources. First thing we had was, or one of the first things that we used was the DOT handbook provided by Mr. Plochet. This was nice on finding prices of things that you can't exactly go to Lowe's and get a price that was good. A lot of the things that's taking place for this project are things we've never been around. So we definitely had to ask somebody or look something up. Mr. Jeter was also a huge help. He's not listed, but we did that on purpose. We wanted to make sure we gave Mr. Jeter credit. He was like an encyclopedia for this. He would take phone calls from business hours, and then after business hours, we spoke to him at 7 o'clock one evening. He was answering all of our questions. Some we thought were really simple, but we couldn't get the answer, and he would answer those. And then, of course, the more complex questions. You see McDonough Marine. This is actually a pretty cool story. So at the beginning, when we was putting all this stuff together, we were researching about barges. I mean, the biggest barge any of us had ever been around was a party barge out on the lake. We didn't know anything about putting a crane out on the water. That was unfamiliar to us. So we was on Google We came across this website, and it seemed to be addressed in Pennsylvania, but it had a little text box that said, if you need any more information, put your information in, put your question in. So we did, and we was actually on Colby's computer, and it actually put his phone number in there. So about 45 minutes after we got off the website and still scratching our heads, we get a phone call from a New Orleans number. And we really laughed at it when we saw it, almost didn't answer it. You know, we just saw, oh, this is funny. We're talking about New Orleans. So here we go. We get a New Orleans phone call. But be dang if it wasn't Kyle Cortello, which works for McDonough Marine. He was a huge help. He answered all sorts of questions out. I mean, just bam, bam, bam with facts and numbers. We was trying to record the phone call, but it didn't work. And at the end of the conversation, we told Mr. Kyle that, like, man, if there's, you gave us a lot of information, but he put himself out there. Said, here's my number. This is my cell phone number. Call me anytime you guys need anything. I'm familiar with I'm familiar with everything around.
Okay, guys, so first and foremost, I want to formally apologize for the connection. I don't know, we had some mishaps here and there. We had some technical difficulties. Our computers were working just fine just before this, and we had a couple trial runs, but everything set aside, I want to thank all of our sponsors. I want to thank Mr. Jeff Plochet from Girders for being a lot of help to us and our team in other construction. I want to thank Mr. Jeter again, countless hours that we spent with him on the phone. You know, like Luke said, some questions that were difficult, some questions that were easy and we couldn't figure out. I want to thank you guys for giving us a piece of your time again, for joining us here on Zoom and making worth with what we got. So I want to thank you guys so much. And if you guys have any questions, now would be the time.
All right, please submit your questions through chat.
Okay, that's Mr. Jeff Plochet. I'm not sure if y'all can see the question. Asked, what did we plan to do with the equipment during the high river period? Actually, by that point in time, we will already be done with the pile driving, so we can have those two cranes on barges, and one of those land cranes will already be gone. All we're doing at that point, I believe, I had to look back at the schedule, but I believe at that point we're almost to pouring the concrete. I think we have all our girders set and everything. So the only equipment that we'd have, I guess, laying around, as you would say, would be that one crane on land, and then also just any yard equipment, such as like a sky lift or for anything moving around materials, and just maybe a bobcat for cleaning up, just things like that. It wouldn't be near as bad of an equipment cost. I would like to say that we could shift the crane back, save ourselves, a month and a half, 2 months worth of money. I just don't know how practical it would be and how much the cost associated with that. But most of our equipment would be out of there, so that would help some.
All right. Did you guys see the question from Mr. DeVille? How much float is in your schedule?
The float in the schedule, here, 1 second. Grant, are you sharing the screen?
Yes.
You go back to the P6 slide. We'll talk about that. All right. So there's our schedule. As you can see right there on the furthest most right column on that left side of your screen, there's our total float. It just kind of depends on what activity that we were going for with how much float each one of those have. I'm not exactly sure the official number on total float of the entire project, but those floats were auto-calculated by us based off our relationships between activities.
To answer Mr. Pike's question, I believe Mr. Pike was the one who asked what kind of cranes we're using on the barges. Is it Mr. Pike? Yeah, those were Manawa 4100 cranes.
To answer Mr. DeVille's question about calculating rain days, Mr. Jeter sent us a sample worksheet with all the rain days and all the holidays on it. And so what we did was that we assumed that worksheet with all those holidays for each month was for if we were working the full 30 days a month. And since we weren't doing weekends, we took a ratio of those rain out days and put those into heavy bid randomly for each week. And so it automatically randomly put them in during each week. It just kind of brought our weather days down a little more than if we were, working the full 84 hours a week. But that's how we did that. I'm actually not sure what NOAA is. He was asking if it was referenced. I'm not sure. Mr. Jeter, do you know what that is?
National Oceanic and Atmospheric Administration.
Got you. Okay. We did not reference that. I guess we could have looked it up at least.
I think Mr. Harlow and Mr. Plochet both were asking a relatively similar question about how we were going to work around the daily activities. Wharf A is only on the south. I'm without looking at it, I think it's the southwest corner, but if you're looking at the picture, it would be on the other side of the wharf, the top left-hand corner. We were wanting to keep our barges parallel with the wharf. I mean, with all things considered, yes, there'd be a lot of work going on, but we would like to have the other side of the wharf available for any activities that's going on. We would have to, if there was bigger barges, and I think coming up Mississippi once or twice a month, I think it's once every 2 weeks, there's a big shipment or I remember Mr. Jeter was talking about it. We actually made plans. We just pull everybody out. If there was a big ship, a big barge, something that had to get into the wharf, we were going to have to pull our equipment out for the time being, but we plan accordingly for that.
And adding on to Luke's question is a lot of the same thing about what are we going to do with our equipment during that shutdown. Not the entire project we have barges in the way and the slip. So a lot of the activity can really remain the same, considering that there's still an old wharf A there. It really won't. Once we get the barges out, it really won't affect the activity as near as much as it will while we have our cranes on barges there.
Hey, Ashley, what's the time period? Because we're quadrupling down with our cranes. It wasn't a very big time period. We had all the cranes there anyway, was it?
Yeah. If you want to go back to
the schedule in front of me,
Grant,
30 days.
Yeah, it wasn't a ridiculous amount of time. Let's see. We should be done driving all of our piles, and I can't read the actual date, but it looks like around the middle of September of this year. So that's starting June 1st into September. That's kind of the whole reason we really wanted to go for this 4 crane thing, and we really researched it and made sure that that's not going to be so much, because we figured the faster that we can get that part of the project done, the rest of the project doesn't take up near as much space, and we can kind of spread it out a little bit more than getting those piles in the ground and set.
Yeah, I mean, we calculated, we optimized space. We calculated to see if we were going to save money, if it was going to be too much. We ended up saving time and money on both of that, using 4 cranes and getting rid of 3 as soon as we were done.
And at the end of the day, they need their wharf back. They need to get it. So it's going to be a little bit. We felt it'd be better with a little bit of a delay.
All right, one more chat question.
Was the bad weather downtime duration defined by the client? In reference to the 2 month shutdown, yes, it was. We just randomly kind of thought about it. I was just thinking, what are we going to do if this water rises like it does just about every year? It feels like, to the point where it's just not safe to work around. And so we immediately asked Mr. Jeter what he thought about it, and he recommended asking Mr. Cloche. So he was the one that really laid that out there for us and defined what months would be our best time to anticipate that to happen. He's got several questions here. Someone wants to take the next one.
I'm assuming when you're asking, how did you present the delay to the client in a competitive atmosphere? When you're saying competitive, are you meaning how? I'm not sure I get the question. Are you referencing? Would you mind typing back in there? Are you referencing how we're in a competition with bids, or is it kind of feeding off the other question, assuming maybe the client told us about that delay?
Yeah, we're not actually sure if all the bidders were accounting for that same duration. Not to be, rude or anything to them, but we thought if it was a great idea, we didn't really want to share it with other groups. But I'm not sure how many people. I'm sure a lot of people did calculate for some, but I'm not. We were all taken back by the fact that it was actually a 2-month delay. We had no idea that it'd be that much. So I'm not sure. I think that I think it's ideal to have that little bit of extra time just in case something like that were to happen. I think it's better to account for it and it not happen than to not account for it and end up being 2 or 3 months longer on your project than what you told the owner.
With respect to our bid and estimate, we tried to kind of under promise and over deliver. So we tried to make it as worst case scenario as possible, just in that way, if it does happen, we accounted for it. And if it doesn't happen, we just finished that much earlier.
All right. Any more questions for this group? Well, gentlemen, good job and thank you.
Thank you for your kind words, Mr. Ploche.
Thank you, Mr. Ploche. We appreciate you as well for sponsoring this project.
Have I withdrawn the co-host permission from all of you? Can you tell?
Yes, sir.
Let me find the next group. Just bear with me. Alex Roberts, where are you?
Oh, Mr. Jeter, disregard my text. I just now saw that I was able to be unmuted. I'm here, Mr. Jeter.
Okay, and let me find Michael Woods. Is he with you?
No, sir. He is in the meeting though. Let me double check.
He's under MLW 063 at lawtech.edu.
All right, should have 5 of you that are now co-hosts. I've unmuted you. You should be able to start sharing.
It says it's disabled, Mr. Jeter.
What is disabled?
Screen sharing.
Bear with me. Okay, Michael, you should have screen share now. All of you ready?
Sir.
Go ahead, guys.
So we are Taco Corp, and we were tasked with bidding the reconstruction of the Chalmette Slip Wharf A in Arabi, Louisiana. I'm Michael Woods.
Alex Roberts.
Gary.
Morgan Hall.
And I'm Cameron Hadley.
So this is just a little presentation outline, and it's color coded with the slides so that you can just use this as a reference if you're viewing it later or whatnot. Our general project goals were to stay within the provided budget of $30 million, which included Wharf A and F, although we were only bidding Wharf A. Minimize and improve upon the expected duration of 720 days, and to limit and minimize the disruption to ongoing maritime operations at the Arabi terminal. And these goals and guidelines were provided by the Port St. Bernard Harbor and Terminal, published in the request for qualifications. And to the right there, I have the highlighted areas that we would have to coordinate with that particular terminal. And I thought of possibly having them move their temporary steel pier down to that next docking station there to give us a little bit more space to work.
So our foremost concern for completing the reconstruction of Wharf A and the Chalmette Comwater Slip is to reduce the impact to the ongoing maritime and port activities by utilizing special equipment to minimize disruptions. Taco Corp was contracted as an independent cost estimator for the upcoming reconstruction of Chalmette Slip Wharf A. The estimated cost was $15,541,090.76, and the project duration would be 346 days.
Okay, so for our construction sequence, we broke the entire sequence down into 3 main phases, including a pre-construction and post-construction. For phase 1 being the delivery and driving of our piles. Phase 2 would be all the substructure, girders and bent caps, and then phase 3 being the superstructure, including all the deck slabs and everything that is involved with the superstructure. And then with the pre-construction having the notice to proceed, our mobilization, and post-construction having our inspection and substantial completion. So starting with our pre-construction, as you see, we always have to start with our notice to proceed, which will then lay out or do our construction layout, and then we'll move forward with mobilization. For phase 1, we'll begin with a delivery of both our timber and our steel piles, and then phase 1 will include the driving of all those piles as well. In phase 2, we'll begin with our concrete retaining wall, and then we'll begin installation for our U-beams, our bent cap plugs, toppings, risers, and shear keys, and then moving on to our LG36 and box beam girders. And in phase 3 will be everything for our superstructure, including the back wall, the deck haunch, and pedestal, all of our slab work, and of course the curb going after that, and being finalized with our mooring bits. And then we'll be concluding with our post-construction, which will be for our inspection, and of course, as we hope, ending with our substantial completion. And that will conclude our construction sequence.
So this is a snip of our critical path from our construction schedule. As you can see, it has just our major activities that are going to delay or continue the project forward. And this is going to have that 346 days is going to be dependent on this. For this slide and the following slide, we did include adverse weather days as well as days for high water and hurricane, just since we're in South Louisiana as well. This is our full construction schedule. So it's going to include every activity for each one of those that Alex just listed, as well as just some minimal activities that will be included as well. This is our cost summarization. So this is a list of all of our bid items given to us at the start of the project, and we were to find the unit prices with the given quantities to get the total price that we received or that we completed with just a little over $15.5 million.
So here's our material pricing for our sheet wall piles, our steel pipe piles, our timber piles, and our corrugated sheet decking. For our steel piles, we used pipe option 2, as it was described to us in our project plans. And we also used pipe option 3, which are a 2-foot long, 48 inches diameter and 3/4 inch thick that were welded on top of each steel pipe. So material pricing for our reinforced steel and our concrete. For our superstructure, we used 4,500 PSI Class A1 concrete. And we decided to use, we had 2 bid documents, bids for our concrete. We decided to use Lafarge, mainly because they were able to deliver it to us on Saturdays without any additional fees. And we also added in our service miscellaneous fee charges for our environmental fees, our cooling charge, and the NCA 1% additive, as you can see below. So here's our material pricing for box beams, U-beams, and girders. As you can see, we have 2 prices for our product and our haul. And on our heavy bid, we used a hauling sub for that activity to differentiate between the taxes of 2 prices.
Some of the special utilized is the Manitowoc 2250 Series 3 with the Max ER 2000 boom configuration. And as you can see to the right, there's the load capacity chart. And the capability of this crane with the aforementioned boom configuration makes it the ideal candidate for reducing the impact to normal activities of the port. The crane has the capacity to lift any of the materials to be used in this project off the barges from the inland side of the wharf. This will reduce our footprint on the 300-foot wide slip and drastically minimize costs that are associated with crane barge activities.
So another piece of special equipment that we used was the Putzmeister 70Z boom pump truck. It is the largest pump truck available on the market. Some of the key features are that the boom can be operated using either A or Z style folds. There are advanced ergonomic systems to help with the operator. You have precise and consistent vertical control of the hose end, and the 5 boom sections have up to 208 degrees of articulation. The reason that we chose this truck was because we wanted to pump the concrete from a truck on land rather than doing any of the pouring from a barge. So the net horizontal reach of 213 feet and 7 inches allowed us to do that. And the output capability of this truck is 210 cubic yards per hour.
So one of the first activities that's necessary for this project is driving timber piles for this project. We will be driving 1,532 70-foot timber piles to be driven flush with the ground with a vibra hammer. At this 270 foot by 72 foot back right section of the wharf, pictured on the top right corner of the slide. Sheet wall piles will then be driven to surround the section, excluding the north side that contains the retaining wall.
Next highlighted activity is driving of the steel piles. There were 119 steel pipe piles that will be driven along 11 vents, and 10 fender piles will be driven as well. The layout for these piles retrieved from the project plans is shown to the right. Each pile is 48-inch in diameters with 5/8-inch thick walls, and prior to driving each pile, as Hector mentioned before, we'll weld a 2-foot by 48-inch by 3/4-inch thick steel pile section atop each bend and fender pile, and it will be removed once the driving is complete. And this is done to protect the top of the pile so that it's not damaged during the hammering process.
Our next activity highlighted is the placement of the U-beams, girders, and box beams. The placement of girders and beams will be made possible using the Manitowoc 2250 Series 3 crane. We will also utilize a barge with a 800 horsepower towboat to assist the crane to place the precast structures that we are not able to reach on land. U-beams will be placed first, connecting to the steel piles and running vertical per the plan view. Next, they will be filled with styrofoam and have 8-inch toppings poured on top. And then the box beams and girders will then be placed on risers and run horizontal per the plan view.
Highlighted construction of the overhang. These overhang forms will be used in 2 separate places. First, around the perimeter of the U-beams to assist in pouring the topping, and then later it will be used to pour the deck slab. These forms will extend 6 feet to allow plenty of access when pouring the deck slab's 4-foot overhang called for in the project plans. And on the bottom of the screen, you can notice the cost and labor associated with installing these deck forms.
Next, we have the placement of our corrugated steel sheeting. According to the bid documents, support angles of the decking are to be installed flush against the top flange of the concrete girders. The net area of the steel sheeting is equal to 33,192 square feet. We have a kind of an example at the bottom right corner of how that would look like. The allowance for additional concrete necessary to fill the voids in the set in place deck forms is shown via the heavy bid in the following slide.
And as he just mentioned, this is the heavy bid activity for the corrugated steel sheeting. It includes the 4,500 PSI concrete allowance at 9 cents a square foot, and also includes the SIP metal forms and equipment and labor associated with the task.
We wanted to give a special thanks to Bow Brothers Construction and Mr. Jeff Plochet for their invaluable support during our most educational term at Louisiana Tech yet. We also wanted to express gratitude to Mr. Jeter, our professor and a diligent advocate of the Construction Engineering Technology program at Louisiana Tech. We wanted to thank him for his mentorship and guidance, not just through this project, but our whole collegiate experience. So thank you very much, Mr. Jeter.
Thank you.
Can we answer any questions? I want to see if I can get to the chat here. Go back to that. Can someone else pull the chat up in our group?
I've got it pulled up right now. I don't see any questions as of yet.
There it is. See that? Somebody just sent a message. I can see that, but I can't pull it up.
Alex or Morgan? Hector, can you see the questions?
Question was, are there any liquidated damages? I don't believe we accounted for any liquidated damages, such as maybe you're talking about the damaging to steel pipes or the timber piles while they're being driven. No, we did not.
Well, liquidated damages going beyond the completion. We did not account for any liquidated damages on that.
All right. The other question, do you have only one crane for the entire project? What about piling hammer sizes?
All right. No, we also have a 150-ton crane used for driving the timber piles. And that would occur simultaneously with the driving of the steel piles and the larger crane to kind of advance our schedule. And as far as the hammer, I have to reference our estimate to get the exact size of the hammer. One of my other group members has that in front of them.
I believe I can pull it up.
I'm going to go ahead and answer the next question where it says, is your schedule based on calendar or business days? We based our schedule on calendar days.
And also we have our schedule set as 5 10s and a half day on Saturday as well.
Next question.
Can somebody read that question?
Are you driving the piles from the barge? If so, were there any provisions for conducting a barge stability study? All of the timber piles were driven from land.
We accounted for, in our heavy bid, we accounted for 42 days of driving pile using the Manitowoc 2250 from a barge. We didn't account for the survey or whatnot, or the stability survey or whatnot.
Then we have a question that says, how much contingency did you add to your estimate? I'm trying to understand the question fully. We're talking about contingency. We had a 12% markup. I'm trying to.
So as far as that, including the 42 days using the deck barge, I mean, the crane is capable of reaching further. So the 42 days is if they got into a scenario where they felt that it was unsafe to reach that far with the hammer and the line weight and the weight of the pile as well, that we could put that crane out there. So that somewhat as a contingency.
And the next question is, how did you plan to install the permanent steel sheeting? I'm trying to think of a way to
I suppose we're going to set it in place with the smaller crane and have our laborers up there to get it in place. I guess we could have detailed that a little more.
All right, any more questions?
To reference the earlier question about the pile hammers, I found that on the steel piles, we had a Delmag D100 pile hammer along with a vibration hammer to start off. And on the timber piles, we had a diesel pile hammer with a 32-inch
Wow.
lead.
The vibro hammer is going to drive the timber piles as well as start the steel piles.
Yeah, sorry.
One more question.
We have a statement, Michael, so you see, it says all the slides and graphics in our presentation are impressive and the age that you should follow along. Thank you for your comment. I really appreciate that.
Morgan and gentlemen, you did a great job. Thank you.
Thank you, Mr. Jeter.
Thank you, Mr. Jeter.
Have I made all of you co-hosts? Austin, Pace, where are you? Carly, can you hear me?
Yes, sir.
Is Austin on here?
He was.
He's right
Oh,
there.
there he is.
I'm here. I recognize him.
All right, are you with someone else? Or are you on? I cannot find you in my list of participants.
He's on there with his name, Austin Pace.
Oh, there you are. I finally found you. Okay, sorry about that. All right, give me just a minute to. Okay. You should be ready to go.
All righty, thank you. Okay, this is our capstone 2020 project. We did the Chalmette Wharf A. Our team name is Capstone and Gown. I'm Carly Lofton.
Mike Knowles.
Janet Randall.
I'm Riley Smith.
Austin Pace.
Oh, it's not working. Give me just a second. It's not working.
Austin, please unmute yourself. All right, go ahead, Carly.
Okay. Capstone and Gown is acting as an independent cost estimator for the construction of Wharf A, located on the Port of St. Bernard Chalmette Slip in Araby, Louisiana. We had to provide the owner with an accurate cost of the project, with plans only being 60% complete. We also had to provide the owner with a schedule. We had a deadline of May 4th, 2020 at noon to provide these items to the owner. Jeff Cloche at Bow Brothers Construction Company, LLC is our sponsor. For this project, we knew that the first step would be to look over the plans and start breaking them down into each different activity. From there, we discussed what kind of equipment and personnel would be needed for each of these activities. We then added each activity to heavy bid and assigned the crews, equipment, and durations. While working on heavy bid, we also added all of the activities to P6. Once they were into P6, we added their durations, predecessors, and successors.
So there were quite a few details that if you weren't looking hard enough, you could very well miss them, like the haunches that sit on top of the LG36 girders. If you weren't looking closely enough, you'd never notice that they were there. It's just a 2-inch tall strip of concrete that acts kind of as a riser for the slab. There's some other details that were more noticeable and had several details on them in the plans, such as the risers and shear keys. The risers are the square of concrete that sits on top of the topping on the U-beam above where each pile is, and almost all of them have a different elevation, and they get taller toward the crown line and shorter toward the water line, shorter toward the water and land. And then you have the shear keys that rest in between the risers on piles M and L and K on bents 1 through 6, and piles E and D and D and C on bents 7 through 11. And there's a lot of little details like that you need to look over the plans several times and read all the notes and look over every detail. And here we have typical elevation views of bents 2 through 6 and bents 7 through 10. We also have the tabulated elevations for each bent as well. So something that's pretty well required and we hadn't really thought a whole lot about until toward the end, but with the help of Mr. Jeter, we came up with the overhang jacks to help form up the overhanging edges, as well as really have a platform to work on. We've got them set to be set up on both sides of each U-beam, as well as the outer edge on the box beams on the water side.
Okay, here is a screenshot of our heavy bid software that we use for estimating the cost of our project. We included the bid items that were not given to us in the bid sheet to develop the rest of our project bid costs. We use simple math to calculate the sheet and steel piles by taking the weight and multiplying it by the given square foot dimensions. This calculated the price per pound, and then we converted it to the price per square foot, which gave us the bid quantity. For the other bid items, we referenced the bid sheet to obtain their bid quantities and their units. We also took into account all that we would need for this project and added the activities, crews, labor, equipment, and materials accordingly to allow each bid item to be possible to fulfill. We had to determine the shifts and crew hours for each activity, and we decided that our crews will work Monday through Friday with 10-hour workdays. We also used the quotes provided to us from multiple companies to determine the materials and their price. Here we show our bid summary that was given to us after we did the calculations of our taxes, our markups, and the shifts that we put in. And our total ended up being roughly around 18 million in heavy bids.
Some of the concerns that we had while working on this project was definitely like the river rising, because it does it every year. And it's only been getting worse. In the past, it wasn't as bad, but now it just seems like it keeps going up. Then there's the flooding on the job site. There's about 100 rain days per year in New Orleans. So you have to figure that out and account that for that into your calendar for your P6 Primavera. Another concern we had is how are we going to get these timber piles to the site? These are like some big piles. And what we came to a conclusion with is we're going to store them on a yard just up the river and have them delivered by barge to the crane, and it'll just drive them right in. Another concern we had is the equipment that we would use to drive these piles.
So as Carly mentioned earlier, 60% of the wharf project had already been completed, and our team was asked to give an estimate of the remaining 40%. And we also had to create a schedule of the entire project on P6. So production rates and material costs not provided by the first 60% of the project were either provided for us or we found them on RS Means. Research of certain equipment we also conducted on and researched on the internet. Also, Turner Steel Company from Bridgewater, West Bridgewater, Massachusetts, provided us with the weight per foot and the price of the connectors used to connect the timber piles to the retaining wall. And also, of course, Mr. Jeter was a tremendous help in giving us information on things that we didn't know or didn't have any experience with. This is an image of our schedule. In order to be as efficient as possible, time management was a key. So during the construction of the wharf, multiple activities, including driving sheet piles and timber piles, were being completed, all while steel piles were being driven from a crane barge. So like as the last half of the steel piles were being driven, the U-beams were being placed on the first half farther down. And which this also practices time efficiency and safety. And our basis on our schedule was Monday through Friday, 10-hour days.
Here we have some examples of the material codes that we're giving. On the left, we can see the material code for the beams, the box beams, the U-beams, the LG36s. And they also included a quote for how much it would take to haul them, which was very convenient. And that comes from the Gulf Coast Pre-Stress Partners. On the right, we have the CMC commercial metals. They gave us a quote for our reinforcing scale, the rebar. And also, if you could read that right there, it has a little price per trip.
All right, Capstone and Gown would like to thank you. It's a big thank you to Mr. Jeff Plochet of Brewer Brothers Construction Company, LLC. Your hand in this project for us was very beneficial. Thank you to Mr. Jeter, and thank you to everyone else who's attending for listening to us and giving this your attention during this time.
And should you have any questions after all of this, we have our emails and phone numbers if you need to get in contact with any of us. Thank you for your time.
Does anyone have questions for this group? Can y'all see the first one?
What was the basis of the 20% markup shown? Well, because we were over water, we had a minimum 15% markup that we could give our workers. So we decided 20% just to make sure that they had that for them.
All right, 2 more questions.
I believe this is a lump sum. Excuse me, a lump sum. And we didn't take into account the owner's continuous operations, I believe, just because this is a renovation of the wharf. It was very deteriorated. I don't know if we accounted for any damages for delays. I know we added a couple more materials on top of what was necessarily required because, I mean, those things are, it's going to happen. Your materials are going to get damaged.
So for the, what assumptions did you have based on the incomplete nature of the plan set, which was, the previously 60% completed project? So there wasn't really I guess that's what you're trying to specify, or what you're specifying. So we came in and had to complete the estimate on the other 40% of the project, and anything that wasn't included in the previous, we had to come up with ourselves, or we were provided with information from either Bow Brothers or Dr. Jeter, or research from ourselves.
Did you get a quote for the builder's risk policy? No, sir, I don't believe we did. I don't believe we even really considered that.
As for the piles, the timber piles and the sheet piles are going to be delivered by truck. The steel piles will be delivered by barge. The steel piles are the one that are going to go to the yard because that's going to take, I believe we have it as.
And that kind of has to go
19
along
days
with
of work.
the owner operations of the project. So as this is going on, we're not going to have, there wasn't enough area or space for the project to be storing materials. So everything's going to be arriving while certain activities are going on, like your steel piles while they're being driven. Barges are steadily coming in with them loaded on. Tugboats are coming in with steel piles loaded on barges, and they're taking them off. And so that's how we save space, you know, when there's not really any space provided, so to speak.
All right, any last questions for this group? All right, Carly, Janet, gentlemen, you did a great job. Thank you.
Thank you.
Thank you, thank you, Mr.
Thank you,
Chair.
Mr. Jeter.
We are the A team. We were tasked with the Chalmette Slip Wharf A in Arabi, Louisiana. That is going to be built by Bro Brothers Construction.
My name is Bud Allen.
Jacob Finley.
Brian Grigsby.
Miles Mayhew.
Mark Russell.
So the first picture we have here is the current state of the wharf. As you can see, it's very deteriorated. This is taken from Google Earth. We were tasked with being the independent cost estimator for Bro Brothers. They gave us, or we were given the cost of the demolition, so we were only building the new wharf, as well as a few other costs were furnished to us, such as the construction layout. Here we have the overall look, looking down at the wharf, so you can see it is an active wharf with a couple other ones. In our plans, there were some mentions of another wharf that they were working on as well. And the Mississippi River, you can see it's flowing right by, coming right through this area. And here's an actual picture from the plans, another picture from the plans that were only given to us at 60%. So there were a lot of assumptions on if there were any changes to come up in the future. And we had the deadline of May 4th, starting about giving us about 7 weeks total to estimate this project.
So, excuse me, some of the risks and challenges that we saw pretty much immediately looking at this project. One was going to be weather, working down in New Orleans and on the river. Weather was a big factor. So we referenced Louisiana DOTD's adverse weather days. And then we also added some more just because of the weather being so unpredictable and river conditions. With the river rising, we knew that they slow down river traffic sometimes, and that may affect it and affect our work. Another one was that we were going to be going through 2 hurricane seasons in this project. So that was a big issue with weather. And then our laydown areas. So we weren't sure that the laydown area at Wharf A was going to be big enough. So we are using Bow Brothers Marine Yard, which is 8.5 miles away, but it does have good highway access, which keeps the girder trucks moving. We're staging the girders and the barges there. And then the timber piles and some small tools like welding machines, concrete tools, we're staging at Wharf A. The timber and sheet pile, something we noticed about that immediately was that we were going to have to be using 2 different hammers for those. So that was something to think about. Worker productivity, how long we're going to be working. We looked at 10 hours for 5 and 6 days. We looked at 12 hours a day for 5 days, and we eventually landed on doing 12 hours a day for 6 days a week. So giving them Sunday off, working Monday through Saturday. And we ended up with a 10.5-hour productive day for each day doing that. And yeah, next slide, please. And then you can see here our job site and the Bow Brothers Marine Yard there.
So a big chunk of this project, probably the largest single bid item, is the driving these 48-inch pipe piles. We're going to do that with a 4100 on a barge, 4100 ringer, not a crawler, and she's going to have 280 foot worth of stick. We're going to be using an APE 206 to vibrate the piles down to about approximately 50%, and then we'll impact them down with a Delmag D100. The way we're going to do this is we're going to prefab several dozen 48-inch pile gates, and over the course of about 2 weeks install a pretty rigid pile template. And when we get to pile driving, we're going to operate in 2-day cycles. The first day we're going to come in, we're going to pick and stab 4 piles into the template and vibrate them to approximately 50% of the tip cutoff elevation. And the second day, we're going to come in, pick up that impact hammer, and drive all 4 piles to completion. Depending on driving conditions, I believe that we might be able to get an extra 1 to 2 piles every cycle. Next slide, please. The 2 main cranes we're going to use on this job are going to be a 4100 ringer and a 2250 crawler. Both of us give us enough reach and capacity to do whatever we're going to do to achieve the tasks set before us. The 4100 for pile driving and the 2250 for sitting our girders. These are a couple of pictures to illustrate our construction procedures for driving these 48-inch piles. On the left, you can see a pair of 48-inch piles stabbed into gates, and those gates are sitting on cross beams on soldier piles. And on the right are 3 48-inch piles stabbed into the template immediately prior to driving. Just for the sake of clarity, that derrick barge there is about from boom heel to the top of the tip. She has about as much headroom as that 4100 that we're going to be using. On the left here, ground release shackles, how we're going to be picking them up out of the hopper barges. And on the left is a detail of a pile gate. To save time and money in fabrication, in lieu of using rollers as seen here, we'll probably just use some plywood shims on the inside secured to the sides of the box beams. And actually using those plywood shims is not only cheaper, but it helps maintain the plumb of the pile when you're picking it after you stabbed it to begin vibrating. Next slide, please. Here we see the D100 we're going to be using on the left, and on the right, a set of offshore leads. APE 206 Vibro, it's a little bit heavier version of the 200, a couple extra eccentric motors and a little bit more metal, giving us more weight to sit that pile a little bit farther down when we're vibrating. The pile drive, we also have to drive about 1,500 70-foot timber piles. And to do that, we're going to be using a Terex HC80 crawler. Hammer of choice is a Delmag D22 with fixed leads and a hydraulic spotter. The reason we chose this lead setup is so that we don't have to fool around with setting up a template for these timber piles. We can go in and survey out the locations of all of our timber piles, and with a GPS attachment to these leads, the operator can just pick up that pile, set the lead, and operate his leads in such a way as to get that pile right where it needs to be without a whole lot of fooling around with extra work on a template. We're going to walk that HC80 onto crane mats inside the cofferdam area and begin driving. And we're not going to stop driving for about 70 days. we figure we can get 22 piles a shift. On the left, you can see this is an HC 185, so a little bit bigger crane, but a similar lead setup, fixed leads, hydraulic spotter, and a diesel impact hammer. On the right is our laydown area that we plan to use. We're going to be getting a couple trucks in at a time of timber piles. Not enough to overfill the area, but enough so that we've always got enough material on hand to keep production rolling and to stage some small tools as well. Now, the other big piece of crane work on this job is setting all these precast concrete girders. And we're going to be using 2 Manitowoc 2250s. And along with 1 push boat. The push boat will be present during most of the project, along with 2 190-foot deck barges. We're going to have 1 2250 on a barge with 200 foot of boom to lift and set the girders onto the pile plugs. And then we'll have another 2250 crawler at the Bow Brothers Marine Yard to lift the girders from their truck trailers onto the barges. And installation of the steel diaphragms will occur simultaneously with the setting of the girders. So next slide. Here's a couple pictures of 2250s just to give you an idea of what we're going to be using. 2250 on a barge, and on the right is a 2250 setting a much larger girder than what we'll be dealing with into place.
We received a lot of current quotes from different people, and here's a few that we chose to go with. We chose Lafarge for concrete, Gulf Coast pre-stressed partners for the beams and girders. The rebar, we chose Commercial Metals, and for the steel bridge deck forms, we chose New Millennium Building Systems. And here's the price to go along with the timber piles.
And so for this project, we were tasked with building a schedule, and we chose to use Primavera P6. As you can see on the screen, this is our schedule. Our start date is June 1st, 2020, and our expected finish date is February 7th, 2022. Now, we'll be using 526 work days, and that equates to 617 actual days. As you can see on the schedule, there's a very fine split in the beginning. And Jacob, if you'll go to the next slide, we can zoom in a little bit. So as you see here, we have 2 major sections that split in the beginning. The first section is going to be driving the timber piles, as well as pouring the flowable fill and the retaining walls. Jacob, if you can go to the next one, we can go to the next part. And so this is going to be our second major section, which is installing the 48-inch piles. And so from here, we continue with the critical path to the completion of the project. Jacob, if you can go back to the first P6 slide, please. And so some of the highlights that we chose for the schedule, and we determined this by figuring out the productivity rates. We decided to go, as Mark had said, with 12-hour days working 6 days a week. Now this includes Saturday work days, and because of that, we were able to achieve our time.
So here's some our budget broken down into the labor, burden, permanent materials, construction equipment, showing that our permanent materials were a good chunk of the estimate, along with our estimated cost before our 18% markup, and then after that 18% markup. And then there at the bottom is the overall cost of the bid with those furnished costs that were provided to us, such as the demolition and the construction layout. The 18% markup was to account for the float in the schedule, any hurricanes, any damages that may happen, as well as we would be working in 3 different calendar years, and we wanted to make sure if it was set up on a pay interval that we were making sure that our guys were getting paid and we weren't taking out big loans or anything such as those.
We'd like to give a special thank you to Jeff Plotier and Bow Brothers for sponsoring our capstone project. And we'd also like to thank Mr. Jeter for being a great teacher.
We are the A team. Does anybody have any questions?
Unfortunately, we don't have access to a geotechnical report or drivability analysis in the area of Chalmette. However, I have experience with driving piles in a delta environment, and if this is anything like Southeast Texas, we're probably going to have 50 to 100 feet worth of mud, and then we're going to hit sands and clays. So, like I said, we don't have a geotech report for this one.
And Mr. Jeff Ploche asked, do you think there would be inefficiency with working 6 12-hour days? So we did account for that, and what we did is we determined that we'll have about a 10.5-hour productive day, and that is what we plugged into the schedule.
Yes, sir. We did consider the requirements for working around the slip and the beam of the barge. I think the largest barge that we're going to have is 72 feet. That's going to be that 4,100 ringer barge. And given the dimensions of the slip, I believe that the owner will be able to get their ships in and out, their bulk carriers and barges. If need be, we can pick our spuds up and get out of the way if they got something larger coming in. And we have plenty of float in the schedule to account for that as well.
All right, last call for questions for the A team. Don't let up on them.
This project was a lot of fun.
All right, gentlemen, you did a great job, and thank you.
Thank you, Mr. Jeter. Thank you, Mr.
Thank you, Mr.
Ploche,
Jeter.
as well.
The last team that we have are the Capstone Critters. Here's the Capstone Critters. And they had a unique project. It was suggested in the May 2019 Industrial Advisory Board meeting to have a capstone team work with the civil engineering team and see how well it worked. And this is the team that I selected to work with the civil engineering capstone team. And I will let these gentlemen tell you about the project, and then they will share with you their thoughts about working with the civil engineering team. So Capstone Critters, it's all yours.
Thank you, Mr. Jeter.
Put it in present mode. We're not seeing on
Make
our.
sure your screen, you're sharing screen one.
Having a little trouble sharing the screen here.
Good old Zoom.
Should be good now. Good afternoon, everybody. We're the Capstone Critters, as Mr. Jeter said. My name's Jeb Kraft, Edward Gray, John Romig over here, and Joseph Hart. And this is our project that we worked on. It is the Shinny Lake Bridge drawdown structure. So just a little bit about this project. There's currently a bridge and spillway structure located in West Monroe on the Shinny Lake. It's on LA 3033. And the Ouachita Parish Police Jury currently controls the lake level there. And they're keeping it at 6 to 8 foot below where it's usually maintained due to the fact that this bridge and spillway structure is at the end of its design life and it may be unsafe for higher flow rates. So they're currently keeping the lake lower than normal. Now, our goal here is to develop a sequence of construction and a project cost estimate for a earthen levee and a road traversing the top of it in the same location as that current existing bridge on LA 3033. So I'm going to give this to Joseph here to show you a few images of where our project is.
So here's an image of our project location. Up to the top right is the West Monroe area. So here's Shinny Lake right here where my cursor is. And at the end of this red arrow here is where the bridge location is. This is LA 3033 running through here. I-20 running up here. So that just gives you a little information on where this project is located.
So here we just 3 images for examples. We want to show basically different levels of lake at different times. The number 1 up here shows basically the lake when it's like really, really low. And then number 2 would basically be, if you went out there today, we went out there, I think Tuesday, and went just visit and take some pictures. And that's about what it looks like. It's really, really high, just I guess from the rain and everything. And then the 3rd one, we kind of wanted to show that there's a natural creek on the spillway side towards the bottom on the south side of the bridge. And that we wanted to show that because that comes up into play later on.
So here's a couple more site pictures. To the top right is a view of the bridge from this would be the southwest, looking to the northeast. This would be the lake side of the bridge right now, and you can see there's some trash starting to build up, and it's building up behind this. On the bottom left is the current flood control structure there. Typically, there's some gates that would go in these spots right here, but they're broken and washed out, so it's desperately in need of a new system to control water. So with this project, we will be removing the bridge, so we will have to relocate traffic. So this is the proposed route of relocating the traffic. With this, we were in talks with the LADOTD, and we did things like alerting the local law enforcement, because this is a main route into town, into West Monroe from rural Ouachita Parish. So this is our proposed route, and it's not very much of a detour, and it could still get them into town easily.
So here we have the designs that were provided by the senior civil engineering design team. As you see on the left, we have the section cut of the levee, which shows us, how wide our base levee will be, and then also you can see where the culverts will run through the levee and how far they are. They're 4 feet from the bottom of the culvert is 4 feet from the bottom of the levee. They're 92 feet long. And then over on the right side, we have a section cut of the levee, which shows you how long the proposed, the new levee would be. It's about 200 feet. For the road, we did about 260 to accommodate tying it back into the existing road. And then you can also see that the pipes are 6 feet spacing from center of the pipe. And then here, so on both sides of the levee, we will have a head wall secured to the culverts. On the river side of the levee, where the water is outflowing, we will have additional 6 inches added to the thickness of the head wall to accommodate for the canal gates that will be put onto the culverts to help control the water structure. These drawings are Louisiana DOT spec drawings, and they were provided by Mr. Jeter. And then on the lake side of the structure, we will have the same head wall, but it will remain at 6-inch thickness because we will not have the heavy gates attached to them.
This image here shows the pipes that we are using. They are Contact Ultra Flow 16 gauge corrugated steel pipe. We're going to have a polymer coating on the pipe. They are 48-inch diameter. The entire length of the pipe is 92 feet. So as you can imagine, that's pretty long. They will come in 25-foot sections. You'll have 3 25-foot sections, and then the fourth section will be 17 feet to add up to the total of 92. And they'll be held together with bands there. And the depth of the pipe is listed down there. We would like the inlet of that pipe to be 6 foot below lake level, so it can adequately draw down the lake whenever need be.
So here is a little bit about the canal gates and pipe grates that will be going on either end of the pipe. So on the left, we have the canal gates. They will be going on the spillway side of the pipes, and they will be used to control the lake level. As you can see, or as I mentioned earlier, I talked about a little bit, the current flood control structure there is not really doing its job right now. So with the installation of these new gates, it'll be easier to control the lake level. Here's a little bit about them. They're Waterman C10, 48-inch diameter, obviously matching the pipes. They weigh 950 pounds, very heavy. And then the grates, which will be going on the lake side, they're mainly there to prevent trash and sticks and limbs from getting into the pipe and clogging it up. They're just going to be fabricated out of steel and then placed onto that head wall that Edward talked about.
So for the project, we decided to use P6 Primavera product that we're using all of our classes for our schedule. This is just the activity list showing the breakdown of the actual schedule. Next slide. So the next slide actually shows our Gantt chart and actually shows our activities stepped out with our predecessors and successors, showing the actual path of the whole overall project. We went with 5/10s for work days, and I think our overall project was about, 77 days is what we came out with. So yeah.
And here we have our estimate recap. This shows us, our total labor costs, materials, and then our markups, and then our bonds also. Actually, our labor came out to be 75,000, and our materials was about 150,000. And then from our bonds, additional 4,500 there. With the markups, we went up to 60,000 in costs. And then here's our bid items, which actually shows, our main, all the main items from our project. As you can see, our majority of our costs came from our sheet piles were expensive, and then our dirt. We ended up bringing in 12,000 cubic yards of dirt for our project, and our total bid price ended up being 463,000, just shy of 500,000.
So just throughout the process of as we were working with the CE group and just brainstorming, I remember our first site visit, as we went out there, we kind of brainstormed and thought about ideas of what we would have to do. And one of the key points that we thought about was we'd have to put sheet piles down to basically keep the water off of the construction area. And a nice idea we came up with was we'd be able to put the sheet piles down in the ground before we would basically deconstruct the bridge, and we could actually drive the sheet piles off of the bridge. So that was helpful. And as you can see, the top, we use Google Earth as a little tool to help us calculate some lengths of our actual distances. And the top line shows basically where the sheet piles would be located. And then the bottom line shows we would put like a little potato levee per se, a levee of sorts to just keep the backflow coming from that natural creek that's on the spillway, so it wouldn't flow back up into our site. And then we also needed to figure out, well, what kind of pump are we going to use? How much water are we going to have to pump out? And we went ahead and did some calculations, and then we actually ended up using Google Earth, and it shows we're about 12,000, 13,000 cubic yards of water would be located in that area. That's just a little tool we used, and that's how we decided which pump to go with. And then we, as you see to the left, we came up with a cool little ideas. We could utilize the public gravel lot that's right there that as a laydown yard. It's state-owned property, and then it would come out helpful to lay down our pipes or gates, the grates, any forming material, any box with tools and anything that we would need to leave on the site. So then the next thing, some extra points that we kind of discussed was, so what do we do with the old bridge structure? We thought about, we located a scrapyard about 10 miles away. We could haul off, metal to there. We have a landfill. It was Magnolia Landfill. I think it was like 15 miles on the east side of Monroe. We could haul off. There's creosote beams that are actually there now that they put in after to help restabilize the strength of the bridge, because it's at its its in life. So we could bring that there because you can't really do anything with it. It's creosote. And then we also thought about, we could take some of the concrete that's actually there, crush it up, put it downstream, and use it as like erosion control for the product. So it'd be a sustainable, recycle type idea. And then we also talked about, Mr. Cheater gave us this idea. You could resell the creosote beams if you wanted to. People buy them all the time. I don't know legally what that would do, but it's a neat little idea we thought about. And then another thing, I guess, some small things is sanitary and restrooms is, porta cans and porta restrooms. Well, there's actually a public, facility right there. It's about 40 yards from the bridge because it's a public boat launch, state boat launch. You can see the little blue building. So we'd be able to utilize that. So that was another thing we didn't really have to budget for. And then, like I said earlier, about figuring out what kind of pump and how much, what size pump we would need. That was one thing we kind of kicked around, and like I talked about earlier, how we figured that out.
So we just wanted to talk a little bit about the CE senior design team that we partnered with. We partnered with Laney Skelly, Katya Opel, Michaela Klaus, and Casey Staller. And it was a pleasure working with those young ladies. They're some of the finest that Tech has to offer, for sure. And, we got a lot of our information from them, but it was really a good learning experience because they came to us and asked us about feasibility, some of the stuff that they were designing. We called them up and asked them questions about what they were giving us. It was very informative time to be able to learn and interact with an actual design group to help put this project together. And we couldn't have been paired with a better group of young ladies. We'd also like to thank our project sponsor, D&J Construction, and Mr. Ryan Laborde. We had a lot of help from him, and it was a pleasure working with him as well. We got nice D&J construction ball caps there. And we'd also like to thank our professor, Mr. Jeter, for all of the stuff that he's taught us over the last 4 years. It's been a pleasure coming through this program and learning from him for sure. And we'd just like to ask if anybody had any questions. Mr. Ryan Harlow asked, how did the team account for flood control while the existing building was out of service and the new installation was constructed? So before we started demolition, anything like that, and we used a small part of the way we built it on that side, and we had a pump on site to our level. Everything blocked out there to get overall store construction. Mr. Shane DeVille asks, were you told to add overtime to your bid? And
no, we weren't told to add overtime.
Mr. Ryan Laborde says 3-part question.
So Mr. Ron LeBeau asked, did your team account for undercut that may be necessary once the construction site is drained between sheet piles? So not necessarily. Once we put the sheet piles down, we accounted for we were going to keep a small pump on site just for, so are you necessarily asking basically the foundation level of the cut of the dirt? Or are you asking like water flowing through the ground underneath and eroding out? That's I'll come back to it. But how much lift of dirt will we require? I think we went with this 12-inch lifts. It's compacted, so it's 12-inch lifts compacted rating each. That was just a LADOTD standard rating that we found. And then, so did you think about any soil stabilization that maybe were necessary? Like I said, we compacted it in 12-inch lifts, and we put that for days in the schedule and stepped it out accordingly. Natural ground. So natural ground, once you drain water before hauling dirt. Natural ground. So I guess, okay. So you're saying how much water is like actually going to be in the dirt, or how dry it's going to be once you pump it out. Okay. So no, we didn't account for that. That's a good idea.
Mr. Shane DeVille.
Mr. Shane DeVille, were you anticipating the added cost for overtime to save on general conditions? Yeah, we just went with 5/10s. We didn't put overtime, but we did add a few extra days here and there, just to give us some lee room and some wiggle room to play with. So we were going to drive the sheet piles, like we said, off of the bridge with the excavator. The distance was close enough, and it was, like I said, it was convenient enough to be able to use the bridge to our, our power as a helpful tool. We could actually just sit on the bridge and just drive them. And some of the ones that were closer on the bank, I mean, you can see, you can go around to the sides and drive them too. So we wouldn't have to get a pin barge or anything like that. Thank you.
Thank you very much.
So Mr. Muhammad asks, were there any inspections done on the bridge to ensure the bridge does not fail during pile driving due to vibrations? Like, we did not receive any kind of inspections or anything of that sort. So no, sir. Like I said, we collaborated with the CE group, and they didn't. I believe they didn't get anything like that of that sorts either, because the girls are pretty good. They would have given it to us. So yeah, we didn't have anything like that. Mr. Shane DeVille, is a traffic control plan required?
Yes, it is. We actually showed the detour that we were putting in. Joseph showed a overview of the traffic detour that we sent the traffic on to Highway 34 in our presentation there. We do have signage and putting that detour in our schedule. We have 2 days.
Yeah, we added that to our bid.
Yes, sir.
We estimated for it accordingly.
Of us sending a crew of our guys out, put up signs, and put that detour in.
Thank you very much.
Thank you, sir.
Thank you.
All right. I have.
But she did. She had this for 4 years. Yep.
Leave somebody
design classes.
Yeah, I think somebody was talking.
Yeah.
Well, I thought I would unmute everybody and see if the young ladies wanted to say anything about the project. I will go unmute.
I'd like to add just me personally, and I think all the guys agree. For us, it was a very good experience working with them, because, I felt, generic, like in real life, you're getting plans daily, you're getting updates on designs and stuff in the construction field. So it was nice. Like, every Sunday we met at 4. We sat in on meetings with them and got to discuss things and just sit in, and they would ask us points, and we'd chime in here and there, and we'd help them out and they would help us out. And to us, it was a very good learning experience to work with them side by side, and, kind of see everything go according to their way and according to our way. And it was nice. So I enjoyed it a lot.
Good. I have unmuted the civil engineering team if they would like to make any comments.
We think y'all did a great job. We also believe that it was a really great pairing. We couldn't have asked for a better CET team to work with. And the guys gave us a lot of really constructive help when we were trying to go through the design process. So good job, guys.
I would like to know that while our project was able to be done and completed to a point to where the boys could actually complete their project, I know several other civil groups that we have worked that are in our class may not have been at that point. So if this were to continue, it would be important to note what kind of project each team was working on to see if they could actually complete it in time for the construction group to be able to complete their own part.
I agree. I think this was a unique case that we were able to get all of our work done in a time efficient manner and then be able to also provide the stuff for the guys. But if this were to continue in the future, the projects would have to be very specifically picked to be able to allow for the early completion on the CE side and then be able to pass on the information to the CET guys. I don't think any of the other CET groups were at, the civil groups were at the same point that we were at whenever we were paired up. There were almost all groups were still doing intense design work all the way through last week and even beginning of this week. So it would not really have worked with any other pairing that we noticed for the future if it does continue.
I agree with what both of all of the girls have said. I also wanted to thank you, Mr. Jeter, for providing recommendations in our project that helped us along the way, as well as provided constructability for the CET group.
Great job. Great job. Thank you, ladies. Thank you, gentlemen, for the hard work that you did to make this a success.
Thank you, Ms. Jeter.
Thank you.
All right. Would anyone else like to say anything?
Yeah,
Go ahead.
Go ahead. Hey, yep. You can bring it back by the office, put it in a dump trailer.
All right. Well, that concludes this year's capstone presentations for the construction engineering technology teams. I say that everyone did a fantastic job. Like I tell people, I'll put my Louisiana Tech CET students against anyone when it comes to knowing how to do construction. So great job, guys, and I will see you soon. Y'all have a great weekend. Be careful.